Okay, so here we are talking about paper chromatography. First of all, we need to know paper chromatography, when it is used, where it is used. Yeah, so let's talk about it first before go into the procedure. This is to separate what? Because since it is the separation technique, right? So it must be related to separating something. So what is it separating? To separate colors in soluble dyes or inks. What does it mean? For example, if you have a dye or ink, you are thinking that it contains one color only, but it might have some other colors as well. This is what we can find out. So now here we go next to go to the procedure, like how it is done. Yeah, so in the procedure, what we are going to do, we are going to put all the steps which are needed. First of all, what we will do, we will talk about chromatography paper. Yes, so what are we going to do? I'll be drawing along the way. Okay, so first of all, what is that? Take a chromatography paper. Take a chromatography paper. I draw for you as well. Wait, and draw a baseline with pencil. Now, what is that? Let me show you, so you will understand it better. I am going to give you chromatography paper. I think so. Let's take in black color. This is going to be our chromatography paper. Okay, and baseline, how you are going to draw, you are going to draw here above 1 to 2 cm the bottom. This will be drawn with pencil. Now, why it should be drawn with pencil, as I have mentioned. Okay, here, yeah, also explain it, because we will be explaining each point with the explanation. So draw it with the pencil. Why is this so? So it will not dissolve, because we know that pencil, it will not dissolve, right? So it will not dissolve. And does not interfere with results. Okay. Then, we go next. Once, you have done it. Now, what you are going to do next, now you are going to take your sample. Keeping in mind, to drop the sample, you are not using the dropper, because dropper will be too big. Okay, yeah. So here, what we will be using a capillary tube. Using a capillary tube, what you do, put samples of dye. Put sample, maybe one sample, or you might have more than one samples. I'm going to show you how, of dyes on the baseline. I show you how on the baseline. So here, for example, let me take different colors. This is what? Okay, this is one dye. Then let's take red. This is another dye. And this is another dye. These are the three different dyes that, we are going to take. Now, what we will do. Now we are going to take a solvent in a beaker. Yes, this is also very interesting step to know. So what are we going to do? Take a solvent, any solvent which is good at dissolving, right? Yeah, I give some examples of it, like water, which is a common solvent, but it does not dissolve all samples in it. So we can even go for better solvents, which are like organic solvents, ethanol, acetone. I'm going to write, let me complete this. So take solvent in the beaker and put the chromatography paper, which chromatography paper, where you have already put the baseline and the samples in it. Okay, what else? Making sure, yeah, this point is important. Making sure the solvent level is below the baseline. Now, let me show you what I am referring to. Now, let's take, first of all, I am going to take a beaker. So this is going to be my beaker. Yep, I am trying to draw it nicely, right? Okay, this is my beaker and this is my solvent level, which I'm making sure which is below the baseline. This is what, they wanted me to do. And again, why it needs to be done. Yes, this is very, very important to explain that too when we are talking about. So why it needs to be below the baseline, so it will not wash off the dyes, right? So the solvent will not wash off the dyes. Yes, that's why it is important to make sure that, it is below baseline. Now, next, what are we going to do? Making sure that here, it is covered with lid. This is what here, as you can see, this is what this is, cover with lid. Okay, they might ask you cover with lid for what? This is to prevent evaporation. So your solvent will not evaporate, to prevent evaporation. Yeah, all the exam points we need to cover. Now, what are we going to do? Now let's go down to go further. Let the solvent travel up the paper. Now you are going to leave it. Okay, let me write it. What I want to say next, let the solvent travel up the paper and obtain solvent front. Now, what is solvent front? Let me give you, as we are covering all detail. So here, we will have, this is the solvent front, which is actually the maximum level the solvent can travel up to. I think so I write here. So what is that? This one I labeled here. This is what this is, solvent front. Okay, and what is this? This is actually our baseline. What is this here? This is our solvent. This one you already know, your beaker containing solvent, right? And solvent, whenever, as I said, the common solvent is water. Common is water, but keeping in mind what is the better solvent. Sometimes, water, it does not dissolve. Also, better solvent is ethanol, acetone. Better solvents are ethanol, acetone. Now, what, since, we have taken the solvent front, we have waited for about 15 to 20 minutes or maximum, 30 minutes. Okay. And then, we can obtain solvent from. Now, what are we going to do? What are we going to do next step? Take out, basically, not take out the chromatogram. Now I call it chromatogram because chromatography is done, means these dyes, they have traveled up. Take out the chromatogram and let it dry. Yes, this is one thing. Now next, after that, spray it with locating agent, right? So means something which is helping us locate what? Because some amino acids, they are colorless, right? Not easy to identify them. So you will spray it with the locating agent and warm it. Okay, that is also important. They ask, in the exam, why do you need to warm it? This is to develop color. To develop colors, right? Basically, which colors? To develop invisible colors. So easier for you to find out about them. I put it here, right? Then it will be easier. Then, so this is about making these in color. Okay, now next. Yes, there is also one more step left, which is about calculating RF value. Yes. So here, let's calculate RF value. I make it a smaller so we are able to see this through. Calculate what I am changing the color so it doesn't mix much. Calculate RF value using formula and compare it. Okay, I explain you what is that. First of all, let's write RF. RF, we always write RF, R capital, F small. And here, how will it be written? Let me write it. Okay, distance traveled by dye. Distance traveled by dye. What does it mean? When your dye travels up, right? This was your green color. Let's say, for example, if it has traveled up here, then the red one may be here, the blue one here. So these are your dyes which are traveling, right? Then what else you will have? You will have finally distance. Distance traveled by solvent, or basically distance of solvent front, you can say distance of solvent front. I can put this in the box so we don't mix it up. Okay, now how to do it? Distance traveled by a solvent front, what I am referring to? I am referring to this, right? Distance traveled by the dye is what? This, your dye which has. So for example, if I have taken the example, distance traveled by the dye, I call it A. Distance traveled by solvent front, I call it B. A, B. So A is, for example, 2 cm. 2 cm divided by solvent front, which is actually 6 cm, right? So your RF value, since it is retention factor, no unit, okay, so how much it is? It is gonna be 0.33. So this is gonna be your RF value for green dye, right? Dye 1. Then similarly, you can find out for others. Okay, this is how, we calculate RF value, and, we do about chromatography, which is about separating color. Take each of the point very, clearly, like how do they do. Okay, like here I have given you all the details that you would need in the exam. Let me highlight it. If you still have any question, yeah, you may ask. So this is what we have, this RF value as well. And we have talked about solvent as well. Here we have baseline. What are the better solvents? Ethanol, acetone. So I think so we have covered all details about paper chromatograph.